So now that we've got the idea of the imitation game set up, he thinks it's an important one to examine. Remember, it's to replace the general vague question, can machines think, with the one about, can a machine function in a human environment? Section 3 is the machine in the game. It's a digital computer. Turing goes, you can have a look at that. He goes into some discussion of it. Remember, in 1950, people were not at all really, the general population were, and lots of scientists weren't really working with computers. Some were, but not like today, nothing like today. So you can have a look at that. So it's the second 4 and 5 digital computers and their universality. We don't really need to worry too much about that. They're everywhere today because you're probably watching this video on a computer. So you can have a look at that. That's largely, I think, of antiquarian interest, but it is interesting nonetheless to look at what the situation was when this paper came out, how early it was in the era of computers. Now, I think we can safely say that it's section 6 that he's digging in to really, shall we say, sort of the central aspects of this paper. Not all of them, but by and large, section 6 is where he looks at contrary views on the main question. These are basically just general objections to the whole idea that machines can think. It's not really a critique of the game per se, I don't think. Really, he's just giving us critiques of that historical positions against the idea that thought could be anywhere outside of a human mind. So the first one, not surprising, is a theological objection, right? That's an old one, and it tends to see thought in a certain way as let's say Aristotle did, thought was connected with rationality. And so in traditional philosophy, it was, quote unquote, man the rational animal. Other animals may have, we are a special animal, we're rational, we're the ones with thought. And that's often was connected with theology, and it doesn't have to be either in terms of religion like Christianity or Islam or Judaism or anything like that. It goes all the way back to Aristotle. There was a link between the notion of a particular kind of soul that humans had that was not shared with other animals. So we had a particular kind of soul that it was able to think. It had rationality. Animals had, non-human animals, they had souls too, but their souls were maybe for perception, growth, nutrition, reproduction, things like that. We have those as well because we undergo those functions, but we have this special kind of soul that is able to think and have rationality, and that had a theological connection even in Aristotle, because it showed that we were very much like the prime mover, as he called it, that we shared this ability to be rational. So this connection of thought and theology is ancient. It's before Christianity. It goes back into into paganism, and so Turing, needless to say, he's not entirely clear as to what he thinks constitutes a theological argument. He connects them up with Scripture, and he says, well, Scripture says all kinds of things. It also said that the Earth doesn't move, right? And that we have a geocentric model. He said these are not really good arguments. So I don't think Turing, was terribly interested in looking at the old traditional philosophical / theological arguments on the nature of rationality and thought. He tends to blow it off rather quickly. Whatever reason, I'm not really sure, but he doesn't make too much of the theological objection. He thinks that, by and large, it's tied to Scripture, and scientific pronouncements of Scripture are pretty well dated. So he ties it again to the notion of the geocentric model of the solar system. Okay, so the head in the sand question, that is that, the idea of, and lots of science fiction is full of this, thinking machines, the rise of the machines, they're going to take us over, right? So this is just a dreadful thought that that thought could exist in a machine. A thinking machine is something to be afraid of. And let's hope, as Turing says, this objection goes, let's hope this never comes about. Um, Turing's not at all impressed with this argument. He doesn't even think it's worth refuting. So I'm not sure why he even mentions it if he doesn't think it's worth refuting. But he's not, he doesn't take any time with it, and I won't either. The mathematical objection, he says, is an interesting one, a little better. And he said, you know, yes, Turing was a mathematician, aware of things like Gödel's results, Church's results, and a variety of mathematical results that were developed in the 20th century. And these, without digging into all the complexities, they showed mathematically that certain systems of representation had built-in limits. Gödel's theorem is probably, his incompleteness theorems are the most famous ones, that they showed that if you have a system in logic that's powerful enough to represent certain kinds of statements, that you can eventually in any one of these systems construct a statement that's true in that system, but that system can't prove it. So there is a schism, a separation of ability to be proven in a system and truth expressible in a system, so that there are limitations on what that system can prove. And so some people have argued, well, that shows that we know it's true and we can prove it, but any given system that's powerful enough can't do what we do, so we must be something different or something better. So machines have a fundamental, you know, these mathematical results, people say, you know, show that machines have certain limitations that we don't. Now, you hear this argument a lot, and you have to be careful with it. And Turing takes this argument more seriously than any of the others so far, certainly more than the head in the sand and the theological one. He thinks there is some merit to this one. But he doesn't think that it really holds up. Not surprisingly, he's going to say something like that. We often feel superior to machines that get the answer wrong, but we shouldn't be too, you know, smug about it. We shouldn't take this feeling of superiority all that seriously, because we make mistakes all the time. And we're feeling superior to a particular machine. So and that's something to keep in mind too, that it's we have to be careful between saying something like a given machine will not be able to handle everything, and then moving on to saying, well, that no machine can handle what a previous one couldn't. Machines can keep getting better, Turing is saying. And so that because we feel that we've bested a particular machine, that certainly doesn't lead us to infer, you know, without any problem, that we can best mentally all machines, or all possible machines. So he doesn't think in the end that you can move from, you know, bettering one machine to bettering all possible ones. So in that sense, he doesn't think that even these mathematical arguments, as serious as they are really going to cut in favor of us being something, you know, more special than machines. All right. Now, the argument from consciousness often goes something like this, Turing says, that machines don't write sonnets. They don't feel pleasure, grief. You can't flatter a machine. Machines aren't sad. A computer's not sad when it gives the wrong answer. Computers you know, can't be seduced. They don't get angry. So you can see there's a variety of things that properties, behaviors, capacities that we attribute to ourselves. Like, you know, you can flatter us and all kinds of things. But you can't do that to a machine. They don't have that. They don't get depressed. If a computer doesn't get the data that it needs, it doesn't get upset about it. If we don't get what we want, we often get upset. So Turing says that this view really denies the whole validity. And he said of the imitation game, he said this really is cutting, you know, sort of ruling it out by definition. Now, he said that, you know, if you take this position really seriously, that a computer doesn't really feel, you run into, Turing doesn't say this, but actually where you're going is down the line of the is the problem of other minds. So if I say, well, I don't really know if a machine can feel, Turing says if you push this to its furthest extreme, how would you ever know that anything can feel? The only way to know that a machine can feel or to think is to become the machine and then try and see if you're thinking or experiencing or so to become that which you're questioning in order to decide whether or not that property, thinking or feeling, applies to that entity in question. Well, Turing says if you're going to be that strict about machines, how can you know that another person is thinking? This is the classic problem of other minds. How do you know right now you're watching this? How do you know I'm really thinking that behind my voice and my appearance, there's actually a thinking entity? How do you know that? You're just basing it off what you're basing it on what you see. How do you know that I'm not just some sort of simulacrum or something like that? And Turing says, well, we just get nowhere if we argue like this. And so what do? We just go with, as he says, the polite, quote unquote, polite convention that that we're all thinking. I accept that you're thinking, even if I don't agree and I'm saying, you're not thinking straight or whatever, I'm not denying that you're a thinking individual. And you're not denying I am. That's a convention, because if we don't have that convention, we'll never be able to be sure that anyone else is thinking. So basically, when you go down that rabbit hole, you can't get out. So if you want to go down it with machines and say, well, I just can't be sure they're thinking, Turing is going to respond to you, go, well, you can't be sure that your neighbor, your next door neighbor thinks, or your colleagues are thinking. You can't be sure of anything. So what's, okay, then fine, then nobody's thinking. But he calls that the solipsistic position, which is not quite what solipsism means, but close enough. Solipsism in the sense that, well, I'm the only one that I can be sure of is thinking. I can't be sure you are. And some sort of weird symmetry, I guess I would grant that you're in the same position. You can't be sure I am. So let's adopt the polite convention. So let's adopt the polite. Why not, adopt that kind of thinking, at least with respect to machines, in that we don't demand something special out of them in order to talk about their possibility of thinking, that we have a convention to get rid of when we're talking about us. All right. So he's basically trying to set up a choice that if you stick with this argument, too strongly, you'll be driven into solipsism, or keep the notion of consciousness for us, the polite convention, and then you can accept the imitation, that the machine can play the imitation game, and if it makes it, it makes it. All right. So, but Turing also is very clear about one thing. He doesn't claim that he's solved the problem of consciousness and that he knows what it is. He's not saying anything like that. He's trying to get around that. He's trying to get around all those philosophical problems of, before we attribute consciousness to anything else, we have to answer the question, what is consciousness? That Socratic approach. He wants to get away from that. Right? That was Socrates. Whenever you start talking about something, you should be able to define it and know what it is exactly. He said, no, we don't want to do that. That's not the way to go. We just want to know, if we can attribute consciousness to a machine, if it can play the imitation game and do well, fine. That doesn't solve the question of what consciousness is. He says, it's mysterious, right? He doesn't, Turing says there is even a paradoxical nature of it. And in this sense, he is alluding to the philosophical history of the problems of consciousness, namely that it doesn't seem problematic to say that, I'm thinking, but it would be very difficult to say what part of my brain is thinking. Can you point to, as he said, the problem of localizing consciousness seems odd, right? Like can you point to a particular thing and say thought is right there? So try and figure out that a particular structure is thinking. He thinks that's a little odd, but nonetheless, he while admitting that this consciousness is a problem and it's paradoxical, he is still saying that it could be in other entities than us, and we shouldn't get sidetracked by the whole problem of consciousness when we're trying to deal with whether or not it could be in machines. Consciousness is an interesting problem, but it should be the only issue when we're talking about whether or not machines can think. Okay, so there's you know, fairly the conversation. Put it this way: Turing's writing is getting more interesting as we go. The first little bit, not so much. He's just sort of blowing these off. Section 6.4 is really where it starts to intensify a bit. And then section 6.5 is going to dig in a little bit more, and I'll talk about that in the next video.